Hey there, and welcome. Today we are diving into one of the most amazing and honestly kind of magical processes on our entire planet, the incredible journey of water. I mean, have you ever just looked up at the clouds and wondered, where does all that stuff come from, and where's it all going? Well, you are in the right place, because we're about to find out.
And for this explainer, you can call me Professor Moisture. I'll be your guide as we follow the story of water. Whether it's coming down as rain, beautiful snow, messy sleet, or even crazy hail, it's all part of the very same incredible story.
So, let's just jump right in with a big kind of mind-bending question. The next time you take a sip from a glass of water, I want you to stop and think about this. Just how old is that water? Really think about it. The answer? Well, it's going to surprise you. Believe it or not, the water you're drinking right now is both brand new and ancient. Yeah, some of it might have fallen as rain just last week, but some of it, maybe just a few molecules in that glass, could be unbelievably old. We're talking water that was around when dinosaurs walked the earth. Seriously. So how is that even possible, right? How can water be both new and millions of years old at the same time? It sounds like a total paradox, but the secret is actually one of Earth's most brilliant systems. Here's the thing. We don't really get new water on Earth. The amount of water we have is, well, it's what we've got. It's a limited supply. It's the same water that's been here for billions of years, just getting recycled over and over and over again. And this incredible recycling process, this giant water machine, it has a name. You've probably heard it before. It's called the water cycle. And no, you can't ride it, but it's basically the engine that powers our planet's weather and, well, all of life itself.
To put it simply, the water cycle is just the constant movement of water. It's on the Earth, it's above the Earth, it's even below the surface of the Earth. It's on a never-ending trip from the ground way up into the sky and then right back down again.
And this journey has 4 main stops along the way. Think of them as the 4 key stages. We're going to break down every single one. Evaporation, then condensation, followed by precipitation, and finally collection. So, let's start with the trip up. All right, so our first 2 stages, evaporation and condensation. This is all about how water gets from the surface of the Earth way up into the atmosphere. This is the upward climb, the great ascent into the sky.
It all kicks off with our friend the sun. The sun's energy beams down and heats up the water in oceans, lakes, you name it. This heat gives the little water molecules so much energy that they transform from a liquid into a gas. We call that gas water vapor. And since it's super light, it starts to float up, and away.
And listen, this isn't just happening in some giant ocean far away. It's happening all around you all the time. You know when you sweat on a hot day, that's evaporation cooling you down. Or those little dewdrops you see on the grass in the morning? Yep, they're gonna evaporate too, rejoining the whole journey.
So what happens to all that invisible water vapor once it gets way up there? Well, the higher you go, the colder it gets. That chilly air makes the water vapor cool down and change back into tiny little droplets of liquid water. And when billions and billions of these droplets get together and hang out, poof, you get a cloud. That whole process is condensation.
Okay, so our water went on a big trip. It made it up into the sky, it formed a cloud, but you know what they say, what goes up must come down. So the next 2 stages are all about getting that water back to Earth. So inside those clouds, as more and more water vapor turns into droplets, those droplets start bumping into each other. They merge, they grow bigger and heavier. And eventually, they get so heavy that the air just can't hold them up anymore. And that is when we get precipitation. The cloud has to let it go.
The form of precipitation we all know best is, of course, rain. This is pretty straightforward. It happens when the temperature is above freezing, so the water just falls as a simple, wet, liquid drop. Now, if it gets cold enough up in those clouds, those little water droplets freeze into tiny ice crystals. And as they fall, they bump into each other and stick together, forming snowflakes. And here's a fun fact you've probably heard, but it's true. No 2 snowflakes are ever exactly alike. Isn't that wild? Then you get the messy stuff in the middle, sleet. Sleet is kind of confused. It usually starts as a snowflake, but then it falls to a layer of warmer air and partially melts. But right before it hits the ground, it passes through the cold air again and refreezes into a tiny, slushy little ice pellet.
And finally, we have the most dramatic of all, hail. Hailstones are born inside intense thunderstorms with really strong winds blowing upwards. A little frozen droplet gets tossed up and down inside the cloud, collecting more layers of ice each time, until it's so big and heavy it finally plummets to the ground. They can be tiny or literally big enough to dent a car.
So no matter how it falls, rain, snow, sleet, or hail, that water has to end up somewhere. And that brings us to our last stage, collection. The water gathers back in our oceans, our lakes, our rivers. It soaks deep into the ground, but eventually it all makes its way back to a large body of water, getting ready to start the entire cycle all over again.
And there you have it. We are right back where we started. From the ground to the sky and back to the ground again. It is a perfect, continuous, never-ending loop. A journey that's been happening for billions of years and will keep on happening for billions more.
So tomorrow morning, when you see that sun come out, you'll know exactly what's going on. You'll know its warmth is already starting to lift water from the earth, kicking off that ancient journey once again, and powering the great water machine of our planet. So just remember, that simple glass of water you're holding isn't so simple after all. It has been on an adventure that spans ages, witnessing parts of history we can only dream of. Which really just leaves one last question, doesn't it? What amazing things will it see on its next journey?